Welcome back to my channel.
We've finally reached the final stretch of our series. Today, we begin exploring the project Gemini.
In terms of the fantastic nature of some of its achievements, it even surpasses the Apollo program, but let's go step by step.
As the name suggests, Gemini, twins, was designed for two astronauts to fly, which required a larger spacecraft.
Since the capabilities of the Redstone and Atlas rockets had already been exhausted, the Gemini program used a different rocket, the Titan II. This was a two-stage rocket with a height of 31 meters, a launch mass of 154 tons, and a thrust of about 193 tons.
It used a hypergolic propellant combination of Aerozine-50 fuel and nitrogen tetroxide oxidizer.
The payload it could deliver to low Earth orbit was, according to different sources, between 3,600 and 3,700 kilograms.
This is a very important number, so let's remember it. Now, let's move on to the spacecraft itself.
The Gemini spacecraft was essentially an enlarged version of the Mercury capsule. It had the same conical shape, the same framed construction, with an internal skin made of titanium, an external skin made of the nickel alloy Rene 41, and the cone of the spacecraft was allegedly made of beryllium. The exterior skin was similarly textured, ribbed with transverse ribs relative to the longitudinal axis of the spacecraft. Everything was the same, but the length of the spacecraft increased to approximately 5 meters 70 centimeters. Approximately, because the data varies. The diameter was 3 meters, and the mass increased according to different sources from 3,300 to 3,850 kilograms. Here we encounter the first oops, because, as I mentioned, the payload capacity of the Titan II rocket was 3,600 to 3,700 kilograms. The most frequently mentioned mass of the Gemini spacecraft is within the range of 3,800 to 3,850 kilograms, but we also need to add about 200 kilograms for the mass of the two astronauts in their spacesuits and some minimal food supplies. In this case, if we take the maximum value, the mass of the spacecraft increases to almost 4 tons. This raises the question, who pushed the extra 100 or 300 kilograms into orbit? We don't get an answer to this question, as usual, but this is far from the first oops we will encounter.
So, let's move on to a more detailed examination of the spacecraft.
As with the Mercury spacecraft, let's start from the back to the front, so to speak.
Unlike Mercury, the Gemini spacecraft had two adapter modules attached at the back. Equipment and retro modules. The equipment module contained attitude control fuel tanks, liquid oxygen tanks, and 2 water tanks. One was indicated as water tank, and the other as a drinking water tank. Also, the liquid propellant rocket engine was located there. Additionally, the diagram shows a little figure sitting backwards.
Of course, there was no actual person there. This was simply where the astronaut maneuvering unit for moving in outer space was supposedly stored at the back of the spacecraft. Since there was no room for it in the cabin, the astronaut who carried out EVA was supposed to reach this backpack, get into it, and test it.
However, the tests did not go well, and such device, as we know, appeared much later. Also, this module contained a cooling system. Next was the retro module, which housed the propulsion system for atmospheric re-entry. Its nozzles were directed right at the fuel tanks for the liquid propellant system. Additionally, these modules contained reaction control system, with their nozzles directed to the sides. Immediately behind the second detachable adapter module was a heat shield similar to the one on Mercury.
However, unlike Mercury, it was rigidly attached to the Gemini capsule because engineers decided against using any skirts and jettisonable shields and chose to cushion the spacecraft's landing in another way. Initially, it was even decided to attach a paraglider to the Gemini capsule.
A model of the capsule on a chassis with this delta wing was even made, and accordingly, it was supposed to land horizontally.
However, this idea was quickly abandoned, presumably because there was no place to store such a wing and it was too heavy.
Nevertheless, this gave rise to the hang gliding in America.
However, the idea of a horizontal landing, but on water, was not entirely abandoned, and to achieve this, it was decided to secure the parachutes differently. Just like in the Mercury spacecraft, the parachutes were located in the cone of the spacecraft. However, one of the parachute lines ran between the twin hatches inside a special groove, covered by a thin metal strip, and was secured to a special attachment point in close proximity to the heat shield. Again, the engineers had no concerns about how this line would survive passing through the dense atmosphere when the shield was heated to at least 1300 degrees Celsius, and the spacecraft's shingles were heated to at least 700 degrees. Apparently, like everything else, it worked as intended. Thus, the capsule was ensured to splash down at an angle closer to horizontal. Accordingly, at this moment, the astronauts were not lying down but sitting, almost like in a fighter jet cockpit, and could partially control the flight and landing.
Next to the heat shield was the spacecraft cabin. Its useful volume was 2.55 cubic meters. However, if divided in half, each person had slightly less than 1.3 cubic meters, which is even less than in the Mercury spacecraft. As they joked, it was slightly more than in a coffin, where the volume is a little less than 1 cubic meter. The crew compartment was equipped with 2 aircraft-style ejection seats, because the escape tower used on Mercury was abandoned. This was done to save weight and even because some considered the tower ugly. However, these ejection seats were never tested, because American engineers understood that since the Gemini cabin was filled with pure oxygen, which the astronauts breathed, the firing of the ejection rockets would inevitably lead to an explosion and fire. Therefore, the Gemini ejection system was never tested with the Gemini cabin pressurized with pure oxygen. One test was conducted. Supposedly, a mock-up capsule was built, and either the ejection seats or some prototypes of the ejection seats were placed in it and tested. Note this.
In a pure nitrogen atmosphere. It is unclear what the point of this test was, as it had no relation to reality.
Throughout the entire project, American designers prayed that, thank God, the ejection seats would never have to be used.
Such are the oddities. Right above each astronaut was a large exit hatch. Actually, reviewing these hatches might be a good point to end the discussion of the Gemini space program. Everything becomes clear here. For those who didn't immediately understand, let me explain. In all pressurized vehicles, the hatches open toward the side with the highest pressure. This is done so that the pressure itself presses the hatch tighter against its edge, thereby ensuring airtightness. For instance, on submarines, the hatches open outward toward the high-pressure water.
which presses them and ensures their airtightness.
In the case of spacecraft, where the pressure comes from inside the craft, the hatches open inward, as is done, for example, on Soyuz spacecraft.
Furthermore, hatches are made as small as possible and of the simplest shape.
They are usually round. This is done to ensure that the pressure is evenly distributed across the entire hatch surface, preventing warping and maintaining airtightness.
So, what do we see on the Gemini spacecraft?
A huge hatch of a complex and absolutely irregular shape, meaning that the pressure on it from inside the craft varied in different areas. Essentially, it's like a refrigerator door with an area of about 1 square meter or even more.
Its sealing is ensured by a red gasket or rubber strip that we see around the perimeter.
It's practically the same silicone gasket as on a refrigerator door, which runs in close proximity to the heat shield.
Let me remind you once again that the heat shield heated to a minimum temperature of 1,300 degrees Celsius, and possibly up to 5,000 to 7,000 degrees. The burning temperature of rubber is only 400 degrees, but again, American engineers were not bothered. Let's look at how these hatches are attached.
They are attached with something resembling piano hinges.
Yes, piano hinges.
By the way, there are very few photos showing these hinges. In all museums where the 11 Gemini capsules are displayed, the hatches are either missing, placed separately, or tightly closed with the areas where the hinges were located welded shut with metal plugs, apparently to avoid revealing the flaws and causing embarrassment.
By the way, regarding patches and plugs,
across the entire surface of the Gemini spacecraft, we can see protruding parts held in place by bolts and rivets.
And we see that not all the rivets are in place. It is unclear when they fell off, either after landing or while flying in space. Why didn't these bolts, once detached, cause whole sections of the hull to break off and destroy the spacecraft? More American miracles.
Regarding the equipment of the capsule, despite saving on weight and safety, the Americans did not forget to equip the astronauts with a water gun. What do I mean by this?
The drinking water tank had a capacity of 7.2 liters.
That means if the mission lasted 3 to 4 days, each person had about 900 to 1,200 milliliters of water per day.
Not much, but bearable. If the mission lasted a week or 14 days, each person got about a glass of water per day.
This is clearly a dehydrating diet, yet after splashdown, the astronauts looked quite cheerful.
They didn't seem to have been severely deprived of water for 2 weeks.
So, to conserve water, a water gun was made that dispensed a 14-gram portion when the trigger was pulled. It could be pulled no more than twice in a row, thus getting 28 grams. This means they didn't trust the self-discipline of the adult men, military pilots.
They invented such a metered drinking device, like for animals. Furthermore, according to some reports, there is mention of a device that collected water from the air with a productivity of, attention, 230 grams per hour. I can't imagine what kind of hammam or tropical swamp atmosphere could produce a glass of water per hour. I'm willing to agree that this might be a typo. It was probably meant to produce 230 grams per day, not per hour.
Again, 230 grams per day is a glass of water. For 2 healthy men, it's nothing. But here we encounter 2 more nuances. Firstly, this device is completely absent from the diagrams, and secondly, and more significantly, we return to the fact that the astronauts breathed pure oxygen, not the atmosphere.
So,
where would the water vapor come from?
In that case, the water vapor could only come from the astronauts' exhaled air. Consequently, how many days would they have to breathe in the cabin for this device to collect a glass of water in a day?
As always, questions without answers.
Further, according to the astronauts' recollections, they mentioned that they vented urine overboard.
This means they did not have any devices for recycling urine and extracting water from it, unlike what was done on the Soviet stations Salyut, Mir, and is now widely used on the ISS. But this raises the question, how could they technically vent urine overboard?
As I have already mentioned, Soviet spacecraft had toilets operating on the vacuum cleaner principle.
There was a hose with special attachments, for men and women, which suctioned human waste, both liquid and solid, into a reservoir.
Theoretically,
If desired, this tank could vent the contents outside, although this was not done on Soviet spacecraft and recycling was used instead.
in American spacecraft, however, there were no toilets.
The astronauts flew in something resembling diapers. The question is, how in zero gravity could they squeeze or somehow transfer the contents of these diapers into a device to vent urine overboard? By the way, how did they change diapers? The spacecraft was very cramped. It was impossible to even slightly rise, let alone stand up. This could only be done by opening the hatch. Therefore, it seems likely that the astronauts spent the entire mission in a single diaper. What can be said about this? They can only be sympathized with, because on Earth, elderly or sick people have their diapers changed at least 2 to 3 times a day, while these guys spent 4 to 14 days in their own waste.
I can hardly imagine the smell in the cabin and what kind of atmosphere was there.
The next point. As we see, the capsule was not equipped with an airlock for spacewalks, which were part of the Gemini program.
The astronauts simply opened the hatch and exited into space. On all other spacecraft before and after the Gemini flights, depressurization, if not an emergency, was at least a serious off-nominal situation to be avoided at any cost. Here it was a completely normal situation.
Vent the oxygen, go out into space, do your job, get back in, close the hatch, and everything is fine. What could have happened to the electronics, which were in a vacuum for half an hour or more, could have been heated by direct sunlight to 120 to 150 degrees or even higher, etc.
These questions remain unanswered once again.
Further, the cabin contained control instruments, and in the upper part of the cone, as I already mentioned, there was the parachute compartment and reaction control system thrusters.
Their nozzles were directed sideways. Remember this information, as it will be useful later.
As I already mentioned, the spacecraft did not have a fairing.
Like the Mercury spacecraft, it was simply mounted on the Titan II rocket and thus passed through the atmosphere twice, once during launch and once during re-entry.
Due to the absence of even a minimal fairing on the spacecraft's cone, the rocket essentially looked like a blunt-tipped shampoo tube. Such a flat top was naturally expected to increase drag, which would take some engine thrust and, combined with the ridged skin shingles, cause increased vibrations.
However, everything went nominal, and no accidents occurred during the Gemini missions.
That's probably all there is to say about the spacecraft's design.
Surprisingly, only 2 unmanned launches were conducted under the Gemini program. Recall that the Project Mercury had 7 unmanned launches, 3 of which were unsuccessful, and 2 were with chimpanzees on board. Here, only 2 unmanned launches, but on the other hand, what launches they were.
The first test launch of the Gemini 1 spacecraft took place on April 8, 1964. The spacecraft was put into orbit, completed 3 orbits, after which the mission was considered accomplished. NASA lost interest in this spacecraft, and it remained in orbit for almost 4 more days before entering the dense atmosphere, where it disintegrated. This was because, attention, 4 large holes had been drilled in its heat shield specifically for this purpose, to ensure the spacecraft would self-destruct in the atmosphere.
At first glance, this seems like nonsense. Firstly, why not test the spacecraft for a complete cycle? It would have been an additional opportunity to test the parachute system and the heat shield.
After all, if you fear the spacecraft might fall into Soviet hands, you could destroy it, as the Soviet Union did with its Vostok spacecraft.
Why ruin a good thing? Why drill holes in the heat shield? Finally, why even install a heat shield if you intend to destroy the spacecraft?
Don't install it at all. As they say, logic clearly took a vacation here. This point is confirmed by the next mission, Gemini 2, which took place on January 19 of the following year, 1965, and was essentially a suborbital flight again. This was a jump and landing, carried out specifically to test the heat shield.
There were no other objectives for this flight. The mission was deemed successful.
The Gemini 2 capsule splashed down in the ocean and, attention, this capsule may be essentially considered the first reusable spacecraft in history. Because some time after the splashdown, it was launched into orbit again as a small space laboratory. Thus, long before the space shuttles and long before the Dragon spacecraft, the USA already had a reusable spacecraft. In principle, the Americans could have been bolder and recognized not only Gemini 2 but also all the Mercury and Gemini spacecraft as reusable. Because if the spacecraft looks the same before launch and after landing, meaning nothing happened to it, it didn't burn up, and it shows no signs of charring or damage, then, essentially, such a spacecraft should be recognized as reusable. It's unclear why the Americans spent another 50 years developing new heat shields, first for the space shuttles and now for the Dragon spacecraft.
In fact, everything was already created back in the early 1960s.
A thin, lightweight metal skin, either with some kind of coating or not, simply due to special alloys, withstood any temperatures, didn't suffer destruction or overheating, and so on.
That's probably all about the design of the Gemini spacecraft and the Titan rocket. In the next episode, we'll look directly at the manned part of the Gemini program.
That is, the missions themselves.
There will be no less science fiction there. That's all for today. Goodbye everyone.